You don't want to miss this episode of the AI Show where I'll be talking with Bozhong Lin about Arc-Enable ML on Azure. Stay tuned. Hello, and welcome to this episode of the AI Show. Today, I'll be talking with Bozhong Lin about Arc-Enabled Machine Learning. Hi, Bozhong. How are you?
Hi, B. I'm great. Great to be here.
Super happy to have you here on the show. Yeah, I'm really excited about your feature in particular. So having you here is just like super exciting for me.
Yeah, great to be here.
So why don't you tell us who you are and what you do?
Yeah, so I work in Azure Machine Learning team as a product manager, focusing on Azure Machine Learning with Kubernetes in Azure Hybrid Cloud. So I'm passionate about helping customers with their digital transformation and machine learning.
That's great. And you have a big announcement at Ignite, right? Can you tell us what you're announcing?
Yeah, we announced the public preview of Azure Arc-Enabled Machine Learning for Inference. So with a simple Azure ML extension deployment, customers can deploy and serve model on Kubernetes anywhere.
Okay, so just to be clear, so the announcement is just for inference, right? So training was already working before, right?
Right, yes. This builds on our earlier training announcement in June.
Got it. Okay, that makes sense.
Yeah.
So now we have a full picture, right? We have training and deployment. We can do the whole thing on Kubernetes.
Whole machine learning lifecycle.
All right, awesome. So you mentioned Azure Arc-Enabled ML. Can you tell us exactly what that is?
Azure Arc-Enabled Machine Learning enables customer to have enterprise-grade machine learning on Kubernetes easily with a simple Azure ML extension deployment. Customer can onboard the data scientist team with Azure ML service capabilities for full machine learning lifecycle. Customer have access to both Azure Managed Compute and customer managed Kubernetes. They can train and deploy model on whenever they want or whenever business requires so.
And why would people want to have their models on premise? Why is that a good thing?
So through our customer engagement, so we saw two needs for our customers with machine learning. The need to use Kubernetes container platform and the need to have machine learning on premises. Our customer runs into two key challenges when using Kubernetes for machine learning. The first is to deploy and host and maintain a variety of data science productivity tools and frameworks and ensure all those up to date all the time. The second challenge is about automation, machine learning workflow, and scale machine learning adoption in their organization. And for the needs to have machine learning on premise, it varies among organizations. Some organizations have petabytes of data on premise, and it's impractical for them to move the data to cloud. And some organizations simply have compliance requirement to keep all data on premises. While the other organizations essentially have a need to have machine learning in a hybrid environment. For example, they have data in cloud, and then they wanted to leverage powerful cloud computer to train model in cloud. And after model is trained, they wanted to deploy model to on-premises for latency and security requirement. Vice versa, some customer wants to train model on premises and then deploying model to cloud for broader service access. Lastly, organization usually has a portion of machine learning requiring total confidentiality. And in this case, they wanted to have a full machine learning lifecycle on premises. Azure Arc enabled machine learning address all these customer needs well. With a simple Azure ML extension deployment, customer gets all existing Azure ML tools for full machine learning lifecycle, and then they have access to Azure managed compute and customer managed Kubernetes compute. So now they can do machine learning anywhere to meet their business needs.
So that's great, right? Because so many people are already doing that, right? They have their data on premise and they don't necessarily want to change what they're doing. And we're kind of going and meeting their needs instead of expecting them to come our way. So that's really great. So who is this feature for? Who's going to be using this?
Azure Arc enabled machine learning is intended for customers' machine learning infrastructure team. The team usually is responsible for setting up a Kubernetes cluster and enable Kubernetes cluster for the data science team to use. So the data science team can focus on building quality model and put a model into production without getting involved into too much details about Kubernetes.
I identify as a developer more than as an IT pro, and as a developer, I like that.
Yes.
That somebody else has all the tools to make my life easier, right? So that's all great, but I want to see a demo, and I think people watching want to see a demo too. Can you show us a demo?
Great, yeah, definitely. Let me have the screen here. So enable an existing cluster to have Azure machine learning is very easy. It's about like a 4-step. So the first step is connect. You connect the existing cluster to Kubernetes. And then the second step is deploy Azure ML extension. And then the third step, basically you attach Kubernetes cluster to Azure machine learning workspace. And then you create a computer target to be used for data science team. And the last step is basically set data science team use the computer target. So let me show how easy it is to done this 4-step. So here is a cluster that I have on my desktop. So it's a Docker desktop Kubernetes cluster. So I can run a simple command. So az connect, and then connect my desktop cluster, Kubernetes cluster to Azure Cloud, okay? So while it's connecting, so I have already a cluster that is connected to Azure Cloud already. So the second step is about deploy Azure ML extension. You can run a simple CLI command and then deploy Azure ML extension to a cluster that is already connected. So let me run this extension command. Now, while these both CLI commands are running, we can head over to the Azure portal to see an Azure Arc Connect cluster, which is already connected, and then with the extension deployed. So I have a cluster on premise. So this is AKS on Azure Stack HCI cluster on premises, and outer is connected to Azure Cloud, is showing as Kubernetes Azure Arc. And then the resource is created in cloud. And then I also have extension deployed. So you can see the extension is deployed here. So this is the Azure ML extension, right? Microsoft Azure ML Kubernetes extension. This is installed. So we can see some properties of this Azure ML extension. So you can see here, I have enabled a cluster for training and also for inference. So which means I can use this Kubernetes cluster to train a model or deploy a model on this cluster. Now let's say the cluster is already deployed with the Azure ML extension. So I wanted to basically to deploy a model. Okay, so I can easily use CLI command to deploy a model. So here's a project that I have. So it's an image classification model. It's already trained, and I want to deploy the model to Azure Cloud using basically the new Azure Arc enabled model deployment capability, safe rollout with blue and green deployment. I have an YAML, endpoint YAML file, which basically it will create, running a CLI command with this endpoint YAML, it will create an endpoint. And then it uses the computer targeted Azure ML AI show. Yeah. And I also have a blue deployment YAML. And so this will create a blue deployment first. So let me first basically run a command to create the endpoint. So this will create the endpoint. Actually, we missed a step. So in earlier, so after extension in deployment, the third step is about attach the computer target. So we attach and create a computer target. So while the computer target is running, I can go to the directory. Now I can create an endpoint. Now with this simple CLI command, I can create an endpoint. So endpoint is creating, and I can, with endpoint is being created. So I can head over to the portal to see the endpoint here. See, this is the endpoint just being created. Okay, the endpoint creation is done. Now I can create a blue deployment. So blue deployment take time. So let's head over to Azure Studio portal again. So I will show an already existing endpoint, the AI show endpoint, and it has the blue deployment already created. Now we have blue deployment with 100% traffic. I wanted to create another deployment called green deployment. So I have a new green deployment, and then with specifying instance type, which is using a big CPU instance. My original blue deployment, the traffic is not meeting requirement. Now I wanted to change using a big CPU instance type so I can handle more traffic. And so let me start creating a green deployment using a simple CLI command.
So you're going to have one endpoint with two deployments, right?
Yes. Yes.
Yeah. A blue and a green deployment.
Mm-hmm.
And all running on your local Kubernetes.
Yes. And then, so this is running on on-premise cluster. So now it's creating the green deployment. So let's head over to the portal to see this green deployment in action. So if I refresh, we'll see the green deployment is being created.
Mm-hmm.
And this will be very quick. And then we also see the notification here. So while it's being created, and then after this is created, we can change the traffic using this endpoint UI also. So it should be very quick to create a green deployment.
Can you just show us the command of how that would be updated? Oh, it
Okay.
just finished. Okay,
Now,
great.
Now say I want to do update the traffic, okay? Mm-hmm. I can use CLI, but in this case, I prefer to use UI. So let me see, I want to go with 10% of traffic first. And then I just update. I give 10% to green to update. Now I can, once I have traffic, I can go to the tester. I can select green and do a simple test. So let me have the test example here. So this is basically an image. And it's a handwriting digital with 8 images. And then if I test the green, so it gives me 8. So awesome. Which is running well. Now say I want to go back. So everything is tested. It works great. So I want to give all traffic to green. I can just move to 100% and update it again. And this should be done in very quick. Now we see the blue deployment is 0 now, right? Now I can retire the blue deployment. The traffic is all going all to green now. So I can retire, just delete.
And now we'll have one endpoint with one
deployment. So I just showed how easy it is to safely roll out a model with the blue-green deployment.
Yeah, on premises, on Kubernetes.
Yes.
That's what's special about it. That's super awesome. So thank you, Bozhong. This is really great. So, but Azure ML has this one other feature, manage online endpoints, which sounds very similar to what you've shown us. Can you tell us the difference?
So both the online endpoint are built upon Azure machine learning online endpoint. Users use the same set of tools to create and manage online endpoint. For Azure managed online endpoint, it runs on Azure managed compute, and customer doesn't need to manage computer and infrastructure and get a turnkey solution with guaranteed SOA. For Kubernetes online endpoint, it runs on customer managed Kubernetes. Customer has to be responsible for maintaining Kubernetes cluster and ensure online endpoint SOA. So that's our key difference.
All right. So if we want to manage our own endpoints, then we choose Kubernetes online endpoints. And if we want Azure to do the management for us, then we should use managed online endpoints, right?
Yes. Yes.
That makes a lot of sense. So where can people go to find out more?
There's a blog, and then also we have the GitHub available. And then there's official documentation, aka ML doc. All these are resources for you to find out more information and get started easily.
This is so awesome, Bozhong. Thank you. It was so great to have you on the show.
Thank you, my pleasure.
So in this episode, you'll learn how you can use Arc-enabled ML for inference on Azure. This feature allows you to deploy and serve models in any infrastructure on premises and across multi-cloud using Kubernetes. How cool is that? Thank you for watching, and we'll see you next time.